So the first thing we do is with number 11. So for part A it says, how fast is the balloon's what?
Radius increasing.
Radius
Increasing.
increasing when what?
At the instant the radius is 5 feet.
When R is what? 5, right? So first of all, and then it says here in the beginning, it even gives us, what does it give us?
The rate 105 feet per cube.
Yeah. So the given, so the first thing is we read it. We need to identify givens, right? What are the givens? R is 5. What else? I'm trying to find, you notice how fast radius is increasing. So that's the rate, right? So it's going to be d what? D dt of what? D what dt? R, because I want to find this, right? The radius. So that's question mark, right? And then what does it give me? And this is the dead giveaway here. You see this? It says, it says a spherical balloon inflated with helium. Excuse me. What is it? Inflated with helium at the rate of what? So it's increasing, right? See, this is what? What is happening? What is increasing? Is inflating with helium. Inflating.
The balloon.
The balloon, right? So the balloon's getting bigger, right? So what's getting bigger? The distance?
Radius.
No, the radius, yeah. But when you see this here, 100, what was it, pi feet cubed over what? M minutes? This means cubed is volume. So that's d v dt. So this means that you're going to need an equation with what? Volume. What's the volume of a sphere?
4/3 pi r cubed.
Yeah, so it's 4/3 pi r cubed, right? So now I have identified my variables. Now what? P is what? Picture, right? So maybe the picture would have served better. So I have a balloon, right? So you can clearly see this is a sphere, and a sphere has volume. Okay, how do I know it's volume? It was a dead giveaway in the problem. As soon as it says cubed means volume. So, and then minute, d min, or over min, that's dt. So it's just dv dt. And the equation for volume of a sphere is 4/3 pi r cubed. Now we're going to take, yeah, we have our equation, right? Now we're going to, yeah, we're going to do we're going to differentiate, right? Differentiate with respect to, yep, to time. So d dt of this whole thing. And now remember, anytime you take d dt of a variable, it's just the variable goes on top. So what does this give me here? dv dt equals what? Now remember, these are numbers. Numbers go along for the ride in a derivative. So this is 4/3 pi. What is the derivative ddt of r cubed?
R
So just take this derivative.
times
It's 3r what? Squared times what though?
times dr
dr dt. Okay? Now, dv dt, right? And now we read it, identified givens, we drew a picture, got an equation, differentiated, and now S is solve, right? We're going to solve and substitute. So let's plug this in. So what do we know?
Why on this one you didn't put it like times
I did. But I did it behind the scenes. So Maria's question is this. Like, do you agree like this one here is, the derivative of blah blah cubed is 3 blah blah squared times the derivative of blah blah? What goes in there?
R.
R, right? So this is here, right? And then what is dr dt?
Oh, yeah,
That's just dr dt,
Yeah,
right? Oh, no, that would be dt dt.
Because I forgot about the R being
Yeah. It's just a chain rule. But because see, it doesn't go to 1 because this is not t. This is dr dt, right? So then we plug in what we know. What do we know? R is what? 5. And dr dt is what we're trying to find. And what else do we know? We know dv dt is 100 pi, right? So we plug it in. So dv dt is 100 pi.
Doesn't matter if you put the units.
No, when you're plugging in, don't put units. It'll just confuse you. And what was r? 5, right? And we're solving for dr dt. So if you guys notice, I can divide by pi, right? What is 3 times a third? This goes away, right? 3 times a third. Is that cool? What's 4 times 25?
25?
Yeah.
100.
100.
Is this 100?
Yeah, 4 times 4 quarters is 100, right?
Oh, it's alright.
I know, right? So what is dr dt?
Is it going to be...
1? Yeah, it's 1.
1, but now look at the units. Now look. So remember, dv, you guys can't see because this is messy, but dv dt was 100 feet cubed, right? Per minute. So this is going to be minute, right? That's the time, right? But what is the distance unit? Feet. So it's feet per minute.
Why is it always...
It's not cubed.
Why not?
Because r is a radius, one-dimensional, and a volume is 3 dimensions, right? And so this is how you would solve this one.
So that's